Like any star, it will run out of fuel in its core, and it starts changing. It starts bloating and getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth. So imagine looking on the horizon and sunrise is half the sky.
Just minutes ago, after the massive eruption of Betelgeuse, things are changing quickly. After all this time, this enormous star that we have been seeing in the sky has finally blown off a significant portion of itself, releasing a tremendous amount of energy into space. It ejected a huge portion of its surface 7 minutes ago, trembling so violently that experts are in shock. Is this the beginning of the end for Betelgeuse? Stay tuned as we dissect the situation and speculate on what may happen after this enormous explosion. An uncommon view of its last days. Picture yourself standing on the edge of the planet and watching the sky fill with half its light as the sun rises. A big portion of the surface of a star named Betelgeuse burst, sending a massive chunk of the star into space, as NASA just reported. 400 billion times more material was expelled by this event, known as a surface mass ejection, than by the sun during a solar flare. This unique glimpse into the life cycle of a star has astounded scientists who never anticipated seeing it up close. A fresh transmission from space suggested that other stars were perhaps behaving strangely while everyone was still reeling from Betelgeuse's explosion. It's not just any star, Betelgeuse. Huge and plainly visible in the night sky, this red star in the Orion constellation is well known for its brilliant reddish-orange light. Every 400 days, the star appears to be breathing, growing, and contracting like a living entity. But astronomers are at a loss for words after this recent explosion in which the star lost a significant portion of itself. Mercury, Venus, Earth, Mars, and virtually all of Jupiter would be swallowed by Betelgeuse if it were to replace the Sun in our solar system. Its crimson tint comes from the fact that it is colder than our Sun, even though it glows with the intensity of 106,000 suns. Betelgeuse is very close to the end of its existence, although being only 10 million years old, young in the cosmos. Compared to smaller stars like our Sun, which still has billions of years remaining in it, big stars like Betelgeuse burn up their fuel more quickly. Stars like Betelgeuse undergo drastic changes before collapsing and bursting into a supernova when their fuel runs out. One of the strongest occurrences in the cosmos is a supernova. For a brief period, the explosion's brightness can temporarily eclipse that of whole galaxies. It has long been known by scientists that Betelgeuse would blow sometime, but no one is sure when. Either tomorrow or 100,000 years from now might happen. When it does, the sky will be illuminated with a brightness that will last for weeks beyond that of the full moon. This is where things become even more fascinating, though. When Betelgeuse began to fade dramatically in 2K19, many speculated that this may be the beginning of the supernova. Nevertheless, scientists now believe that dust created when the star shed a significant portion of its outer layers is what caused the dimming. The star's light could not reach Earth because of this shroud of dust. Betelgeuse has since brightened once again, although its typical pulsating pattern has changed. The star is attempting to heal following that enormous outburst. However, it's not the frightening aspect. Because elements like carbon and oxygen, which are necessary for life, are dispersed when stars like Betelgeuse erupt, these stars are significant to the cosmos. The cycle of life and death in the cosmos is continued by these explosions, which also aid in the formation of new stars and planets. Astronomers now have a unique opportunity to examine a star in its last phases thanks to new observations of Betelgeuse. Although no one is certain when the star will explode, this outburst may indicate that it is approaching its last explosion. NASA's James Webb Space Telescope is monitoring Betelgeuse closely and following the debris it sent into space in the meanwhile. With the use of this new equipment, astronomers can now observe the star in unprecedented detail, providing new information about what's going on within this fading giant. Earth won't be harmed by Betelgeuse's supernova since it is too far away, but it will still be an amazing spectacle. The explosion can be visible throughout the day and have a brightness comparable to a full moon for several weeks. Until then, Betelgeuse continues as a giant star reaching the end of its life, entertaining everyone on Earth with a celestial spectacle. Galaxies began as little objects and have evolved into a massive cosmos full of stars over time. Remarkably, the James Webb Space Telescope has revealed that galaxies were not as uncommon in the early cosmos as previously believed. Rather, the cosmos appeared to be brimming with them. Much of what scientists thought they knew about the evolution of the cosmos has been altered by this revelation. The discovery of tiny and evolved galaxies by James Webb has the potential to fundamentally alter our knowledge of the origins of the universe and potentially cosmology. Imagine using the most powerful telescope ever created to see into the farthest reaches of space. It is possible that dim, small galaxies will be dispersed far away. Surprisingly, though, these far-off galaxies are not tiny at all. They are almost the same size as nearby galaxies. This contradicts our understanding of the behavior of light in space. Typically, galaxies appear smaller as their light expands with distance, a phenomenon known as redshift. However, James Webb's observations of far-off galaxies seem far larger than anticipated, which begs serious concerns about our current understanding of the cosmos. According to our present understanding, galaxies have been spreading apart due to the universe's expansion since the Big Bang. Light stretches as it moves through this expanding universe, giving the appearance of distant galaxies being smaller. However, James Webb's images refute that notion. Galaxies appear huge and dazzling when they should be weak and microscopic. Scientists are now forced to reconsider how the cosmos is expanding. If the size of galaxies does not decrease with distance, then our understanding of cosmic expansion may require a significant revision. James Webb has discovered galaxies with extremely high redshift levels, which indicates that they are expanding beyond our comprehension. This would typically be consistent with the theory that the universe is expanding faster. These galaxies don't, however, behave in the manner that we had anticipated. They appear large and dazzling, far more developed than we would anticipate for their distance, as opposed to dull and little. This finding calls into question our whole theory of the expanding cosmos. We then investigate unexpected realities from the farthest regions of space. James Webb alien findings: the turbulence that is predicted for the early cosmos is one of the key components of galaxy formation. According to scientific theory, galaxies would exhibit deformed forms and twisted arms as a result of colliding with one another. However, James Webb's image of galaxies appears to be ordered and smooth, showing little evidence of these violent interactions. These galaxies appear peaceful and organized, similar to the galaxies that are closest to us, rather than chaotic. This unexpected smoothness raises two possibilities: either the early cosmos was far less turbulent than previously believed, or there is something lacking from current theories regarding galaxy formation. The age of the stars in these galaxies is where it becomes even more astonishing. Current theories suggest that some of these stars are older than the universe itself. This implies that they before the Big Bang, which is an astounding notion. It shouldn't be possible for galaxies that originated only a few 100 million years after the cosmos began to have stars this ancient. If this discovery proves to be accurate, it may lead scientists to reconsider the universe's age and the laws of physics that explain how it all started. Beyond only changing our knowledge of galaxies, James Webb's discoveries are also casting doubt on the Big Bang idea. This hypothesis states that everything that is visible now began as a tiny, hot point around 14 billion years ago, and that everything has been growing ever since. However, the fact that there are galaxies that are too big and developed for this timescale raises questions about how these objects may have arisen. How can the concept of a single explosive beginning mesh with their existence at such an early point in the history of the universe? We uncover more secrets the more we investigate with the James Webb. A cosmos that is more complicated than we could have ever dreamed is revealed by every new image and discovery. The core rules that explain how galaxies originate, how the universe expands, and even how ancient the cosmos could be are currently being re-examined by scientists. Is the cosmos maybe more ordered than previously believed? Does it have a different expansion rate, or may it perhaps be older than we think? The answers to these queries might fundamentally alter our understanding of reality. These findings also raise more complex, philosophical issues. What does it say about existence itself if galaxies and stars existed before we imagined they could, and if the cosmos is expanding in ways that we cannot completely comprehend? The existence of time itself is beginning to baffle certain physicists. Is time only an illusion that humans create, rather than a fundamental component of the universe's structure? It's possible that the past, present, and future are all simultaneously real and are only hiding from view in the fabric of space. Beyond merely displaying stars and galaxies, James Webb is disproving preconceived notions and forcing us to reconsider our understanding of the cosmos. Every new finding deepens our understanding of the universe and may even cast doubt on some of our most fundamental assumptions about space, time, and the nature of reality itself. Determining the structure and history of the universe has gotten increasingly difficult due to the issue of knowing how matter is distributed across the cosmos. Weak gravitational lensing contributes to the observation of matter clumping in the nearby cosmos by astronomers. However, the cosmic microwave background, CMB, which is radiation left over from the Big Bang, provides a different, smoother picture of matter distribution when scientists go even further back in time. This discrepancy raises a mystery, demonstrating our incomplete knowledge of the universe's evolution from an early, smooth form to the more clumped state we observe now. Scientists are questioning whether we really grasp the forces driving the cosmos in light of these contradictory discoveries. It is suggested by some that new theories may be required to explain the behavior of matter at both tiny and large scales. These novel concepts have the potential to fundamentally alter our understanding of the cosmos, and their resolution might represent a significant advance in cosmology by illuminating the evolution of the universe throughout time. Durham University's Flamingo Project, a massive undertaking, is at the center of this inquiry. The project intends to mimic the whole universe, including both the stuff that is visible to us and the dark matter that affects its structure, using one of the most potent supercomputers in the world. These intricate models, which include everything from massive black holes to whirling galaxies, were produced by the researchers using more than 50 million hours of computer effort. However, despite having access to so much processing capacity, the Flamingo Project is still unable to properly resolve the issue of the various matter distributions. This demonstrates how difficult it is to reconcile the actual evidence we obtain from studying the cosmos with our theoretical theories. It also serves as a reminder of the limitations of even the most sophisticated instruments in the face of the intricacy of cosmic forces. However, this isn't the most annoying aspect. The comprehension of the universe's expansion and matter distribution is a fundamental challenge in cosmology, and it goes beyond simple technical issues. It's encouraging scientists to innovate by developing fresh methods, instruments, and teamwork. Together, astronomers, computer scientists, and physicists are expanding our knowledge of the workings of the cosmos. The James Webb Space Telescope has already produced several fascinating findings, such as the identification of an exoplanet in the constellation Dorado named GJ136c, which is around 49 light-years away. This planet is a top contender in the hunt for extraterrestrial life as it is located in the habitable zone of its star, where conditions may be favorable for the existence of liquid water. The James Webb Space Telescope sensors are essential for researching planets such as GJ13643c. Its mid-infrared instrument, MIRI, assists in determining these distant worlds' temperatures, while its near-infrared camera, NIRCam, captures extraordinarily clear photos of them. Through the examination of light passing through a planet's atmosphere as it passes in front of its star, a telescope can identify chemical components that could potentially indicate the presence of life. Let's now examine the quest for extraterrestrial life in more detail. Significant advance in the search for extraterrestrial life, these findings mark the beginning of a new phase in our cosmic investigation. We are getting closer to finding the answer to the fundamental question, might life exist elsewhere, and if so, what would it imply for us? We will continue to hunt for planets similar to Earth and explore the secrets of space. With the use of cutting-edge equipment, scientists are currently investigating the likelihood of liquid water, a need for life as we know it, on far-off planets. These sophisticated Instruments record extraordinarily fine-grained pictures and data, which aids scientists in comprehending the topography and climate of these distant planets. Measuring the planet's mass is a major objective in order to determine the strength of its gravity and the potential composition of its atmosphere. With each new finding, we get closer to resolving one of the main questions: is life already present on GJ 13633c, or may it be a potential home for mankind in the future? In the process, we want to comprehend things outside of our solar system in addition to seeking solutions. GJ 1363.3c has piqued interest not just among scientists but also among the general population. With the application of this new knowledge, educators may demonstrate to their pupils how our understanding of the cosmos is always expanding. GJ 1363.3c, a potentially habitable planet, integrates scientific concepts into practical investigations. Furthermore, these subjects are more interesting and approachable for general audiences because to media coverage and talks about popular science. Through participatory events like seminars, workshops, and even research initiatives where non-scientists may assist, people become increasingly interested in astronomy. This enthusiasm may result in more financing and support for space research, ensuring that the field of study concerning planets outside of our solar system keeps expanding. However, this isn't the most unexpected aspect. The information from GJ 1363.3c is forcing scientists to reconsider how planets create and sustain life. It's not simply about how far a planet is from its star, according to new study. These days, scientists are examining factors like the types of gases present in the atmosphere, the stability of the planet's orbit, and the presence of a strong magnetic field. The unique characteristics of GJ 13643c, including as its volcanic activity and atmospheric makeup, are being studied to see whether life may live thereunder. Conditions that are drastically different from those on Earth. Scientists are learning more about planets in distant star systems and potential locations for life around the cosmos by examining planets like this one. GJ 153c may change our perspective on the search for extraterrestrial life by revealing new kinds of planets that may harbor life. A realm of strong storms, frigid winds, and profound secrets has been discovered by exploration of Neptune and its massive moon Triton. Voyager 2 reached near enough to Neptune in 1989 to offer a wealth of fresh insights on the planet's atmosphere, magnetic field, and moons. Large, persistent storms like the Great Dark Spot were discovered by scientists, demonstrating how far from peaceful Neptune is. The solar system's fastest winds, reaching up to 1,667 miles per hour, are found on Neptune. This information has altered our understanding of massive planets and prompted further inquiries into the possibility of experiencing such extreme weather so far from the Sun. However, Neptune's largest moon, Triton, is much more intriguing. Triton circles Neptune in the opposite way from all other moons in the solar system, indicating that it was grabbed by Neptune's gravity at a later stage of its existence. In addition to being home to ice volcanoes that spew forth nitrogen gas, Triton is also a geologically active place that may have an ocean beneath its frozen surface. Triton stands out because to its peculiar orbit and activity, which also provides hints about how life may endure in harsh conditions. The instruments we employ to explore these far-off planets are increasingly more sophisticated as technology advances. Scientists can now study Neptune and Triton in more detail than ever before thanks to the Hubble Space Telescope and the James Webb Space Telescope. For instance, the James Webb Space Telescope can see through Neptune's dense atmosphere to provide fresh information on its weather and thermal activity. It's also contributing new information on the cold surface of Triton, which helps researchers unravel the mysteries surrounding these far-off celestial worlds. In the future, NASA's Neptune Odyssey mission, slated for launch in the 2030s, is expected to advance our knowledge of Neptune and Triton. This mission will not only do a cursory flyby, rather, it will conduct an in-depth investigation of the planet and moon, concentrating on their atmospheres, geology, and potential water beneath the surface. Our understanding of how planets and moons form in other star systems and whether or not they may host life may be completely altered by the mission's discoveries. May a supernova wipe out life in far-off galaxies, or may it be able to survive? Please share your opinions with me, and remember to like and subscribe for more conversations.